Let's see a simple example of tolerance stackup analysis. I have applied only size tolerances to the knuckle joint assembly. The first step in tolerance stackup analysis is identifying and defining the problem or requirement. We want this gap should be greater than 0. Otherwise, the whole assembly will not be done properly. Okay, I am going to do a tolerance stackup analysis one day. In this, I am creating first the loop diagram with arrows. The blue arrows shows the upward directions. That means that these dimensions are getting stacked up to negotiate with this overall dimension. Whether this overall dimension is higher or lower than the stacked up dimensions will tell us whether there is a gap or interference. See, I have defined the requirement. That means the gap between the washer and the outer pin must always be greater than 0 to ensure that the smooth functioning of the knuckle joint. Okay, and how I am calculating it, and each dimension in the loop I am labeling it from A to H. I am entering in the column dimension 17.5 and its tolerance plus or minus 0.2. Then I am calculating 17.7 as upper limit, that is 17.5 plus 0.2, and 17.5 minus 0.2 is 17.3, that is lower limit, and equal bilateral tolerance is the upper limit minus the lower limit, and mean tolerance equal bilateral tolerance divided by 2. The mean dimension is now the lower limit of the dimension plus the mean tolerance, that is 17.5. Sensitivity factor, I am applying 1 for all the linear dimensions. For radius here we are applying for positive directions 0.5, for negative directions minus 0.5. Here it is positive direction, I am applying 0.5, and 92.5 is 92.1. How this, see, if the way we are calculating to find out the mean dimension is to ensure that if the dimension is applied with a unilateral tolerance, for example, only in the positive direction there is a tolerance and in the negative side it is not allowed. That means that the upper limit is 92.2 and its lower limit is 92. But if you take equal bilateral tolerance is 0.2 and its mean tolerance is 0.1. So that's the mean tolerance plus the lower limit now comes 92.1. Here if you calculate with this mean tolerance, what is its upper limit? 92.1 plus 0.1, that is 92.5, 92.2, and 92.1 minus 0.1 is 92 here. Okay, that is having a sensitive factor in the negative direction. That's why this value. So overall the mean gap we are getting minus 1.475. Let's see its meaning one by one in this next slide. In the worst case tolerancing model, first we have defined the requirement. That means the gap between the washer and the cotter pin must always be greater than 0, so that we can assemble all the parts together without any problem. So first we are taking the mean dimensions from the previous slide and sensitivity factor and mean tolerances. These are all the mean tolerances. So mean gap for the requirement 1 is dg d sub g we are calculating by multiplying ai, the sensitive factor, into one by one all the dimensions and adding it all together. So positive side and negative side dimensions getting subtracted. This negative sign means there is an interference of 1.5, almost 1.5 mm interference is there in this assembly. And expected variation we are calculating by taking the tolerance added together with its weighting factor, sensitivity factor. That means the negative minus positive value will get subtracted. We are getting 1.55. So minimum gap here we are calculating by using mean gap minus expected variation, that is tolerance, worst case tolerance, that is coming around minus 3.025. This negative minimum gap means there is a huge interference. You cannot assemble this part with this type with this way of giving tolerance to this assembly. If we give only size tolerances, then you see what are the problems it's going to come, or whatever the tolerances we have given, it needs to be optimized. And the minimum gap, it shows 0.075, 75 micron. So still it's going to become more difficult to assemble all the parts together. We will see in the next lessons how we are going to optimize the tolerances, and let us see how the geometric GD&T tolerances are analyzed using worst case tolerance model in the next lessons. Thank you for watching this video.